Good morning, everybody. We have got Timothy and Noah watching. Hi. We've got Torin. Hello. We have got George. Welcome, George. We've got Lucy. Hello. We've got Noah. Hello. Welcome. Hi, Ollie in South Africa. Hi, Ollie. Okay, we've got a challenge question following up from yesterday's lesson. What is 0.35 as a fraction and a percentage? Have a go at that while I do some more shout outs. Let's see who can answer the question. Yay! Hi Sam, wearing his Maths Live t-shirt, amazing. Hi James and Laura in East Yorkshire, hello. Hello Sophie, hi Sophie. Oh, Tom's on it again. Tom was on it yesterday. He's got a couple of answers. I've got Mia and Noah. Hello. I've got Rufus. Hi. Oh, it's a busy lot this morning. Brilliant. Oh, busy. Right. So let's get started. So 0.35. 0.35. So, 0.35. Let's start with the fraction because that will then really help us with the percentage. So 0.35, it's the 3 is in the tenths and the 5 is in the hundredths. And because it's crept into the hundredths, that means it has to be out of 100. So 35 out of 100 is your answer as a fraction. But some of you might have tried to simplify it, which is fantastic. I didn't ask you to simplify it in the answer, so if you've got this, fantastic. To simplify it, you would look, right, is there any numbers? Is there any factors of both 35 and 100? Any numbers that you can that is in those times tables? So they're both in the 5s because you see they end in 5 and 0. So you can divide the top and the bottom by 5. And if you divide the top and the bottom by 5, 7 5s are 35, and 100 divided by 5 is 20. So if you got that answer as well, I know that Tom got it. You didn't have to, but well done if you did. So we're looking at 0.35 as a fraction. This is our answer. And now we've got this as our fraction, it can help us with our percentage. Now percentages, remember, are always out of 100. And because we've got 35 out of 100, it must be 35%. You can't simplify that anymore, like I say, because it's always out of 100. So that's why it's useful to have that as part of your answer as well. Fantastic. Okay, today's lesson. This might be one of a harder Maths Live lessons because the relationship with the problems. So we're doing problems today, linking even yesterday's lesson, but we're applying them in reasoning problems. I won't lie, everybody, they're all SATs questions. I have practiced this a lot recently in the tuition that I do, and I think following it on straight from the lesson is really useful. And there's a range of questions. There are so many questions that come up in exam papers. Not just linked to decimals on their own or fractions on their own, but percentage on their own. But the combination, there are so many, and there's so many different ones. So I want to show you all the different types. Right, this is not all the questions that could happen, but you'll see, and I'll explain as I go along, which ones appear every single time. So again, if you've got the sheet, fantastic. If you haven't, I'll obviously put it on the board. So the first question is, Rudolph, it could be people's names. Rudolph says 0.65 is smaller than, what's our fraction? 9/5. 0.65 is smaller than 9/5, and it asks us to explain why he is correct. So it's not asking us whether he is correct or not. We are told that he is correct. We are told that he's correct, but we have to explain why. And when it says explain, explain means you need to give evidence. You need to show why he is correct. Okay, so a way of doing, there's two different ways you could do this. Now, obviously we've got a decimal and we've got a fraction, okay? Now, what we can do is either convert the decimal into a fraction or the fraction into a decimal, okay? I don't mind which way you do it. I'm actually going to focus on the fraction because I've noticed something straight away. And I'm going to try and convert it into a decimal, okay? So if I convert this into a decimal, first of all, I'm going to make the denominator nice and friendly, like we've always been doing. It's 5, but I'm going to make it into 10 or 100, okay? If I make it into 10, I've got to times it by 2. So whatever you do to the bottom, you have to do to the top. So 2 times 9 is 18. Okay, so 9/5 is the same as 18 over 10. Now 0.65 as a fraction is 65 over 100. Okay. Now, if I wanted to put them in this one into a decimal, do you notice that the top number is bigger than the bottom number? It's true here, but it's true here. So can you say to someone in your room, do you know what it's called when the top number is bigger than the bottom number? Okay. It's actually called an improper fraction. So this fraction here is more than a whole, okay? And we can see it, okay? If I then made it into over 100, okay? So if I change this now, so that it's over 100 and it's matching the 0.65, I've obviously got to times that by 10. 10 times 10 is 100. So then I've got to times 18 by 10, which is 180 over 100. So you know now that he is correct because 9/5, okay, 0.65 as a fraction is 65 over 100, and 9/5 can also be written as 180 over 100. And you can see that they're bigger. You could say that you already know that this is an improper fraction, but then you have to write and explain what an improper fraction is. And I know some of you don't like writing in sentences in maths. It can get a bit complicated. So if you just showed a calculation like that clearly states they've got the same denominator, but this one's bigger than this one, you're great. Okay? I just want to make that clear. When it says explain, you don't need to actually write in full sentences. You can actually show that this could be your answer. That could be your answer. Okay? So just look, comparing them and making them the same. Hope that makes sense. Like I say, this is supposed to be tricky today. Next question. Okay. Write these in order size, starting with the smallest. Now, these questions come up all the time. Every single exam will have a question like this, and all they'll do is change the numbers. So the first one is 3/4, 0.34, 0.7, and 43%. Now this one, I'm going to give you a chance to have a go. Okay, I really want to explain the first one for you, and the improper fraction, and the link and how you can make them the same. This one really does link closely to what we've been doing last week and yesterday, so I want you to have a go at giving that one a go. Yay! A lot of you did notice it was an improper fraction. That's brilliant, well done. Sorry, I should make it clear. So yeah, someone's just asked me what the smallest first, smallest to largest. Always a good part of the question. That could be so easy to get wrong. putting them in the wrong order. Smallest to largest. So let's see if we've got some answers going to come in. Oh, we've got one. Sam's got one. Okay. And what I like about Sam's is that he's written the numbers as they are presented on the paper. I'll explain what I mean by that in a minute. Okay, I'll give you a couple seconds more. Don't worry if you haven't quite finished. Just working it out. Okay. So some of you might not be sure. Some of you might be having a go. So as you can see, we've got decimals, percentages and fractions. The easiest way to do this is to make them equal in the sense that let's make them all into either a decimal, all into either percentage, all into a fraction. So there's 3 different ways of doing this. Looking at this, I'm going to make them all into a decimal, okay? Because I've got 2 decimals, so I'm already sort of halfway there. So I'm going to make these 2 into a decimal as well. 43% as a decimal is 0.43. Okay, I'm just going to put that in brackets. Now, why I put that in brackets? Because I need to remember that cannot go in my answer. I cannot put 0.43 because the question is asking me for 43%. 3/4 is a decimal. Remember, this is one of those funny ones that you need to be able to remember. Okay, quarter, half, 3/4, a third, the ones you need to try and keep in your head. So that's 0.75. Okay. So now we need to put them in order from smallest to largest. So I've got 0.75, 0.34, 0.7. Now, can you see all of them have got 2 digits? You could put a sneaky second 0 on there so it looks like 70. So the smallest is 0.34. Okay, done. Tick it off, you know you've got it. The next one is 0.43, but I need to write 43% in my answer because that was the number, that was this figure in the question. Okay, done. Next one I've got 0.75 and 0.7. Well, they've both got 7/10, but this one's got no hundredths and this one's got 500ths. So this is actually the next one, 0.7. And the last one is 3/4. There you go. So those are ordered from smallest to biggest. Yep, some of you worked it out as a percentage. Amazing. Like I say, there's 3 different ways. You can turn them all into decimal, all into percentage, all into fraction. Exactly the same method. There's no wrong way of doing it like that. So well done. And it allows you, if you're more confident in one, then that's fantastic. Where's my answer sheet gone? Sorry, not my answer sheet. There was no answers on here. My question sheet. Okay. Another question that comes up loads every single time. So here are our symbols. And it says, write the correct symbols in the boxes below. So here are our boxes, and there's 2 to compare. We've got 5/10, we've got 0.05. We have to work out, is one bigger or smaller than the other, or are they the same? And then we've got 43 over 1,000 and 0.43. So have a go at those. Which symbols are you going to put in which box? Obviously you're typing, so if you just want to tell me which one's bigger, which one's smaller, or if any of them are equal, you can do that. But if you do have the symbol, you can do it like that. And again with this, for each question, there's different ways of doing it. Oh, got some answers coming in already. Yeah, the crocodile does always eat the biggest number. Yeah, a great way of learning those symbols. Okay, so let's have a look. So again, two different ways of doing this. You could convert this into a decimal in order to compare, or you can convert this into a fraction in order to compare, and same with the bottom two. I'm going to convert 5/10 into a decimal. 5/10 is 0.5. So when I convert these, which one's bigger, 0.5 or 0.05? Well, they've both got no units, no ones. So if I go next, this has got 5/10, but this has got no tenths. So 5/10 is bigger than 0.05. By the way, this as a fraction is 5/100 because there's no tenths, but it is in the hundredths column. So as you can see, there's two different ways of checking. For the next one, got 43/1000 and 0.43. Now 0.43 is 43/100. 43/1000, right, this is a tricky one. We haven't really done over 1,000 very much. So if you've got a number that's over 1,000, remember when I said however many digits at the bottom is how many should be on the top. Now we've got our tenths, our hundredths, and our thousandths. Okay, so there's actually going to be 3 digits after the decimal point. Now, watch this. If I take away the 4, how many thousandths have we got? 3. Tenths, hundredths, thousandths. Well, 3 needs to go there, and our 4 needs to go next to it, and then there's a 0. And the 0 is a placeholder to bump it along because 0.43 is a completely different fraction. So using that now, I've converted both sides twice. This one's the biggest, okay? Because 43 out of 100 is a lot bigger than 43 out of 1,000. And you can compare the two decimals as well. There you go. Okay. So we've got one more question for this lesson. And if you're a patron and you've got the sheet, you've got the super challenge, which is very tricky, but give it a go and I'll obviously help you if you inbox me. Again, another question that comes up all the time. Take the fractions that are equal to 40%. So we're looking for the fractions that are equal to 40%. And we've got 7/20. We've got 2/5. We've got 14/40. So I'm just going to put symbols here, like a tick box, so you can just see the difference. We've got 30/60. And we've got 40 over 100. Now, I'm going to give you a little hint. Well, not a little hint, a big hint. The question says, tick the fractions, plural. So when it says tick the fractions, that means there must be more than one answer. Simple hint in the question. So tick the fractions. So you know now there's more than one answer. Brilliant, yeah, and that last question, I can see that some of you did it as just the decimal, some of you just did the fraction. That's why I showed you both, in case you did it different ways. That's absolutely fine. So take the fractions that are equal to 40%. Oh, got quite a lot of answers. Okay, again, I'm going to show you a little trick if this question comes up. First of all, I ignore all the answers. I ignored all of them. I don't even look at them. I know I'm going to be looking for answers that are equal to 40%. The only thing I have spotted is they're all fractions. Okay. So, first of all, 40% as a fraction. Okay. I know 40% as a fraction is 40 over 100. Okay. I know that. That's also equivalent to 4/10. Okay. Because if I get rid of the zeros on top like that, it means the same. 4/10 is the same as 40 over 100. So there's my two little facts that I've got ready for me. So if I now start looking at the problems. So I've got 7 over 20, 2/5, 14 over 40, 30 over 60, and 40 over 100. Right, well there's one of them. Brilliant. Right, now I need to start working through the others. The others aren't as obvious. Though there is one that really stands out as it can't be. This one can't be, because 30 over 60 is equivalent to a half. 30 is half of 60. So I know secretly it's not that one. Okay, so I can ignore that one. Okay, 7 over 20. I can convert this so that it's over 100. So 7 over 20, if I times 20 by 5, 20, 40, 60, 80, 100, that makes it over 100 for me. So 7 times 5, 35. They're not the same, are they? So it's not that one. So I'm just working through them, checking, because I know it says fractions. It means more than one. That could mean there's 2, there's 3, it could be all of them. Okay. 2/5. Okay, 2/5, right. 2/5, I'm going to make it so it's a nice friendly fraction. I can times it by 2 to make it over 10. So 5 times 2 is 10. Do the same to the top. 2 times 2 is 4. Yay, it is equivalent. It does mean the same. And the last one, 14 over 40, right, this is a tricky one. Okay, I can make it into a friendly fraction, because 14 over 40, if I halve it, that gives me 7 over 20. Okay, hang on, I'm going to stop there. I'm not even going to go to making it over 100, because can you see here, 7 over 20 we've already looked at and we've already gone, nope, it doesn't work. So here are my two answers. 2/5, 40 over 100. Okay, that's our lesson. Well done. I hope that's helped. I hope I hope that's what I was trying to achieve, is like the decoding of it, the steps, things like that. Taking a step back, not just launching yourself straight into the answers. You can do some working out to get there. That's absolutely fine. If you have, where's it gone? Just want to repeat. If you do have the challenge sheet for today, this is for patrons who take part. Thank you, by the way, somebody saying, oh, I love these lessons. Like, you make these lessons happen, guys. If you're a patron of Maths Live, that's the only reason I'm still able to go and spend this time doing it. So thank you very much. I do love doing them. So there's a super challenge at the bottom. It's quite a tricky one, but use all your knowledge from last week and today and yesterday to help you go through it. And if you think you've got an answer, inbox me and I will let you know. Or if you're stuck, inbox me and I'll give you a little hint. Right, I'll see you on Friday for the times table test. See you later. Bye bye. Have a good day.